Hello, good morning, everyone. Can we start? Who are there? Good morning, continue. Hello, Ramcharan. Okay, so yesterday we were discussing some questions of atomic structure, right? So we'll continue with that and we'll see today chemical equilibrium also. Have we discussed this one? Just check once. The first one we have discussed. Yeah, we have discussed this, right? I think we have discussed this. This one is done also. Okay, I'll cancel this. What about this? This one we haven't. Okay, do this one. Solve this question. Just a second. Hello. बोलिए भैया. Hello. Question number 34. हाँ बोलिए. आज आइएगा ना. हाँ आ रही है. हम आज हम आपको आज अभी हम क्लास ही ले रहे थे. ध्यान से कर गया था. वैसे आप अभी आप आ जाइए और शाम में आप जा रहे हैं तो फिर आप 2 तारीख को आइएगा. हाँ अभी आ जाइए. हम क्लास ले रहे हैं. आप आइए देखो. Question number 34. What is the answer? We've done this. This one we have done. Yes. This was the last thing we have discussed. You see this? This is the last page, fourth one, till 25. Yeah, that's what. Solve this. We haven't done this. Question number 34. Samir is getting C. What happened then? Tell me the answer. What is the answer? Tell me. 34. Samir is getting C. It is based on Heisenberg uncertainty principle, right? Heisenberg uncertainty principle, which says the uncertainty in position, that is del x into del v, is greater equal to, or we can say equal to, h divided by 4 pi m, right? So you see the velocity is given 600 meter per second and with an accuracy of 0.005%, right? So the uncertainty in velocity will be 0.005 of 600, right? So this will be equals to 0.03. Okay. Del x we have to find out and all other things are given, right? Just we have to substitute the value and the value of del x will be, del x is equals to, h is 6.6 into 10 to the power minus 34 divided by 4, pi is 3.14, mass of the electron is 9.1 into 10 to the power minus 31, and then del V is 0.03. When you solve this, you'll get 1.92 into 10 to the power minus 3 meter. In this kind of question, so option C is correct. in this kind of question, what you have to take care of is the unit you must take care of. Okay, then only you can make some mistake. Okay, so take care of that particular thing, unit. Question number 34, option C is correct. Right, next one, question number 35. Question number 35. Tell me. 35, Ramchandran is getting B. What about others? Saimir is getting D. Where is Kondinya? Udvig is getting B. Kondinya, what happened? Tell me the answer. Radius of the first Bohr orbit is x. De Broglie wavelength of electron in third Bohr orbit. Simple one, right? So 2 pi x, 6 pi, like this it is given. So what we can write, directly you can use the formula, okay? Or we can also write, since de Broglie wavelength you have to find out, so that is nothing but lambda, and this lambda is equals to h by mv, right? This is what we have to find out. Correct. So we can use this relation that angular momentum mvrn, where r is the radius of nth orbit, is equals to the integral multiple of what, h by 2 pi, n h by 2 pi. This is the formula we have. And Rn we can write, Mv will write as it is, and Rn will be n square A naught by Z, right? And A naught is nothing but x. So n square x by Z is equals to n h by 2 pi. So we have to calculate h by mv. So h by mv will be what, directly we can solve from here. First Bohr orbit is x. So nothing is given, so we consider Z as 1 for hydrogen atom. So we can write here square, and this n will get cancelled. So 3x by 1, since it is third orbit, so n is equals to 3, into 2 pi is equals to h by mv. So answer will be 6 pi x, option B is correct. Okay, option B is correct. Now, question number 36. Question number 36. What is the answer? 36. 36 is also B. All of you are getting B? Purvik is getting C. Okay. So you see, what is the formula of radius R? This is equals to in nth orbit 0.529 n square by z, right? Angstrom. Now the question is, which hydrogen-like species will have the same radius as that of Bohr orbit of hydrogen atom? So Bohr orbit of hydrogen atom means what? Which orbital we are taking? Bohr orbit means first Bohr orbit, right? First Bohr orbit. So for hydrogen, or this write this any write down as it is. For hydrogen, this will be what? 0.529 n square by 1. Okay. Now, if you see this option, Li2 plus, Li2 plus Z value is 3, Be 3 plus Z value is 4, He Z value is what? 2. Correct? So, one by one, if you see, n value is 2, so 2 is square, 4 divided by 3 won't be equal to this. Right? What we need, if you substitute, since they are talking about the Bohr orbit of hydrogen atom, so it means we are talking about the first Bohr orbit. If nothing is written, only Bohr orbit is written, it means we are talking about the first Bohr orbit. So radius is nothing but 0.529. N value is 1, Z value is 1 for hydrogen atom. This is for hydrogen, right? So we have to find out this. For lithium, if you see, Z value will be 3, N value is 2, so 4 by 3 won't be equal to 5.529. For beryllium, if you see, Rn for beryllium plus 3, this will be equals to 0.529. N value is given, which is 2 square, and Z value is 4. So you see, this and this will get cancelled, and this will be equals to 0.529, which is equals to the first Bohr orbit of the hydrogen atom, and that's why the answer B is correct. Correct? Okay. Question number 37. 37. 37A. The number of radial nodes of 3s and 2p orbital are respectively. What is the formula of radial node? The formula is n minus L minus 1. Number of radial node is n minus L minus 1. Number of angular node is L only. Right? So n value is 3 for 3s orbital I'm talking about. N value is 3. L value is 0 minus 1. So it is 2. And for 2p orbital, n value is 2. L value is 1 minus 1. So it is 0. So it is 2 and 0. Option A is correct. Easy one. Right? Next, question number 38. Following quantum numbers, impossible set. All of you are getting A. Why it is A is impossible? Why A is impossible? Reason you tell me? M lies between minus L to L, right? So it cannot be less than minus 2 over here, right? That's why A is impossible. Question number 39. Question number 39. And 40 are you. The electron level, which allows the hydrogen to absorb photon but not to emit. Why it is 1s? Lowest energy level you can say, and you can also say that for hydrogen atom, 1s orbital only will have electrons, right? 2s, 2p all are empty. Yeah, that is what ground state, lowest energy level. Both are the same thing in a different way, you can say. Hence, option A is correct over here. Right, 39 A is correct. 40, angular momentum in 2s orbital. Are you getting C? Ramcharan is getting C, Saimir is getting B. What is the formula of angular momentum? Angular momentum, the formula is what? L into L plus 1 root over of it h divided by 2 pi. This is the formula of angular momentum, right? Since the orbital is 2s orbital, so L value is what? 0. And that's why the angular momentum is 0. Why you are getting C? How it is C? Ramcharan and Purvik. Okay, this is the formula we use. See, angular momentum is MVR also. MVR is equals to NH by 2 pi. But this formula we use when the number of orbit is given, like in the second orbit, third orbit, like this if it is given. So n value will substitute accordingly. But if the orbital is given 2s orbital like this, then we use this formula L into L plus 1 root over of it h by 2 pi, where L is the quantum number. Okay, so L value for s orbital is 0. For 2p orbital, what will be the orbital angular momentum? Okay. For 2p orbital, the L value is 1, right? So 1 into 1 plus 1 root over of it h by 2 pi. So it is root 2 h by 2 pi. Hence, option D is correct in that case. When we have orbital angular momentum, you will write this, right? Angular momentum will be this. Don't get confused with this. Orbital angular momentum will use the orbital here, L. Correct? And it is important also. Maybe you will not get any question in JEE mains, but in all other exams, BITSAT, CET, Manipal, you will get this kind of question. Very common question. Every year they ask this kind of questions. Okay, must remember this formula. 41. What about A? Does this violate any rule? Option A. Option A. Does this violate any rule? Yes, Hund's rule is violent because what it says that the pairing of electron. What is Hund's rule? Pairing of electron takes place once all the orbital is singly occupied. Right. So here you see this orbital is vacant and the pairing takes place. So this option A violates Hund's rule. Right here, what is Aufbau principle? That the electron fills into the orbital according to their energy in increasing order. Right. So lowest energy orbital fills first, and then the higher one, right? So 2s orbital obviously has whatever this obviously has the lowest energy than this. So this should be filled first, right? So we should have two electrons here, but we have only one, and here it is paired. So this particular option violates of Bohr principle. Is there any violation of any rule in these two options, C and D? Is there violation of any rule in C and D option? No violation. Okay, so C and D is perfectly right. 42. 42. All of you are getting A. What is this orbital? First one. What orbital we have here? First of all, increasing energy, we have to find it out. So we'll just add n plus L, right? So here the first one it is 5. Here it is 4, 5, and 4. Right? So equal number of n plus L value, then we'll check the n value, right? So first one will be maximum, then we have third, and then we have second, and then we have fourth. First, third, second, fourth. Option A is correct. Right? So this is 4P, this is 4S, this is 3D, and this is 3P. Correct? Option A is correct in this. Next. Now you see these questions have been asked in J exam. 50 and 51. In option A, it is minus 34. Option B, it is minus 38. Option C, minus 31 and minus 30. A, B, C, D in order, I'll tell you. Minus 34, minus 38, minus 31, minus 30. 10 to the power minus 38 you are getting. So it's option B. A, B, C, D. The power of 10 is minus 34, minus 38, minus 31, minus 30. Ritvik is getting D. And others are getting B. Ramcharan is also getting B. De Broglie wavelength of a car of mass, this velocity, this h value is given. So we have to only do the calculation in this. Okay. So nothing we have to. There's no logic here. Lambda is equals to h by mv. You have to use all the value you have to substitute and get the answer. Option B is correct. Okay. 51. 51. How did you do, Purvik? Purvik, how did you get the answer? B. So you got 6. What about Ramcharan? How did you get B? See, for the first one, it is given n is equals to 5. So L can be equals to anything from 0 to 4, right? Which can be 0, 1, 2, 3, and 4. So if L is 0, M will be what? 0. If L is 1, M will be minus 1, 0 or plus 1. If L is 2, then again M will be minus 2, minus 1, 0, plus 1, plus 2. If L is equals to 3, M is equals to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. L is equals to 4, M is equals to minus 4, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, and plus 4. So where we have the condition is M is equals to plus 1, right? So we have plus 1 here, right? So 2 electrons will have here, plus 1 here, 2 electrons will have here, plus 1 here, 2 electron here, and plus 1 here, 2 electron here. So we can have only 8 electrons possible in the first case. Yes, correct. See, you cannot, no, Simon, you cannot say P or D, because P and D we can say when you know the L value. Okay, so if L is equals to 1, then it is P. If L is equals to 2, then it is D. If L is equals to 3, then it is F, and then G. So any of these orbital is possible. 5P, 5D, 5F, anything. But the point is, whatever it is, we are talking about one particular orbital because it is plus 1. If suppose we have P, so we have Px, Py, Pz, right? Pz, Px, Py, like this. So out of P also, we are talking about only plus 1. Correct? So this we can take only 2 electrons, right? So 2, 2, 2, 8 electrons here. Is it clear? Tell me if you understood. Right? So we have to only check for the orbital which has +1 m value. So for all these possible value, we have to select only +1, right? So here we have +1, +1, +1, and +1. And each of these orbital can have 2 electrons, so 2 into 4, 8 electrons possible, right? What about the second one similarly? N is equals to 2. So L value can be anything from 0 and 1. These two value possible. If L is equals to 0, M is nothing but 0. If L is equals to 1, M is nothing but -1, 0, and +1. Right? So here in this question, N is equals to 2, L is equals to 1, M is equals to -1, and S is only one value, -half. So only one orbital possible, N, L, M, S, so 2 electrons. Only one electron possible, so is equals to 1. 1 is the answer. Why 1 is the answer here? Why not 2? One particular orbital we are talking about, right? So why 1 is the answer? Why not 2? Just a second. Okay, because S value is given, right? S is -half, and the other electrons in the same orbital will have S value as +half, right? So if S value is not given, then the number of electrons, possible electrons, will be 2. So in any orbital in this kind of question, if S value is given, like how many electrons can have these quantum numbers, if the question is this, with S value is given, then the answer will be always 1. One electron can have only one particular value of S. Okay. Now question number 52. Hmm. Question number 52. The wave number of the first emission line in the Balmer series by wave number is nothing but 1 by lambda, right? So option A is correct. All of you are getting, that's why I'm not solving this. 53. In an atom, how many orbitals will have the quantum number this? 3, 2, m plus 2. Is it C, only one orbital? Yeah, C is correct. You see, these are the questions of JEE Main. 54 and 55. Fifty-four and 55. Fifty-four is D, 55 is B. 55 is again, it's the same question. 55 B is correct. For one, it is 5. It's the same question actually, it is. 54 is D. The formula we use here in the 54th one will be this: E is equals to 2.178 into 10 to the power minus 18 Z square 1 by Ni square N1 square minus 1 by N2 square. Z value, it is given for hydrogen atom. Z value is 1, N1, N2 is given, right? N1 is 1, N2 is 2. You substitute this value, you will get energy, and that will be equals to Hc by lambda, right? So this lambda we have to find out. H and C value, it's also given. So lambda you will get around 1.214 into 10 to the power minus 7 meter. Unit will be this. So option D is correct. Again, this is just a calculation, right? Solve this question. This is equilibrium now. C. Purvik, Ramcharan Kondinya, tell me the answer. Sai Meher and Ritik is getting C. All of you are getting C. Okay, so in a chemical reaction, the rate constant for a backward reaction is this. So Kb is given 7.5 into 10 to the power minus 4, and the equilibrium constant Kc is also given, that is 1.5. So we have to find out the rate constant for the forward reaction. So we know this Kc is equals to Kf by Kb, right? So Kf is equals to what? Kc is 1.5 and Kb is 7.5 into 10 to the power minus 4. So when you solve this, 1.125 into 10 to the power minus 3, you will get option A is correct. Question number 2. Question number 2. नहीं कुछ नहीं निकाल बढ़िया बताए. Tell me what is the answer? Question number 2. Still doing? Should I do it or you're trying? Okay. .118 you are getting. Okay. What about others? Saimir is getting option B. Is it? Tell me. Okay, see. First of all, we have moles of N2. That will be 56 divided by 28, 2 moles. And the moles of H2 will be 6 divided by 2, 3 moles. Okay. And the moles of NH3 we get here is 27.54 divided by 17. 17. Okay. So once you divide this, the moles of NH3 that we get here is 1.62 approximately. Okay. Now the reaction we have is N2 plus 3H2 gives 2NH3, correct? Initial number of moles of N2 we have 2, H2 we have 3, and NH3 we have 0 initially. Okay. Saimir is getting C. So it is 2 minus X, suppose it dissociates, 3 minus 3X, and then 2 minus, sorry, this will be 2X. So the value of 2X is nothing but 1.62 because this is what we are getting, NH3. So X is 0.81, right? So the equilibrium concentration of N2 will be 2 minus X, 2 minus 0.81, which is 1.19. Equilibrium concentration of H2 is 3 minus 3 into 0.81. Okay. Where it is 2 minus 2x. Where it should be 2 minus 2x. No, we have one mole only here, you see. One mole of N2. So 1, so it is x. 3, so it is 3x. 2, so it is 2x. What is the equilibrium concentration of H2 you are getting? Saimir, Ritvik, what is the equilibrium concentration of hydrogen? Tell me this value. 0.57. So this will be 0.57, and then NH3 we have already 2 into 0.81. So Kc is equals to what? 1.19 into 0.57 cube divided by 1.62 square. Is it the expression is correct? This expression is correct? 0.57 it is. What is the answer you are getting here once you solve this? Tell me the answer. Oh, sorry, it should be product by reactant. Correct. So I'll write here 1 by Kc. Okay. What is the answer of Kc you are getting? Yeah, correct, correct. Kc you are getting 11.9. Some mistake we have made or what? Oh yeah, one mistake we made. Can you find it out what? No, not temperature. The equilibrium constant that we calculate, there we make some mistake. Just a second. Just a second. Let me cross check the answer first. Equilibrium concentration of N2 is fine because X is reacting. X is nothing but 1.16. This gram of this 1 liter vessel, the equilibrium mixture contains this gram of NH3. This gram of NH3. Equilibrium mixture contains this gram of NH3 means the mole of NH3 will be this. Can you check this value? What is 27.4 divided by 17? Is it correct? 1.62. 27.4 divided by NH3, is it 1.62? You check once. The approximate value of Kc for the above reaction in this. Okay. Okay, it's 1.62, so it's fine. So number of moles of NH3 we are getting, volume is 1 liter. So whatever this is nothing but the number of moles. So 2x is 1.62, so x is 0.81. So when x is 0.81, so equilibrium concentration of N2 will be 2 minus 0.81, which is nothing but 1.19. This is correct. So equilibrium concentration of H2 will be 3 minus 3x only, which is 0.57, and N2 is 1.62. This is what we are getting. I think it's wrong then. Yeah, it's wrong. There is a mistake they have done. They have actually taken here, I saw it now, they have actually taken the x value 0.18 by mistake. What they have done, they have taken here 3 minus concentration of H2, what they have written, 3 minus 0.54, which is 2.46. Okay, so their Kc expression is this 1.62 square divided by 1.19 into 2.46 cube. When you solve this, you'll get 0.148. You can check. Understood? When you solve this, you'll get 0.148, which is the option we have, right? But what mistake they have made, they have, instead of 0.81, they have taken 0.18, so that this 0.18 into 3 becomes 0.54. So 3 minus 0.54 is 2.46. That is what they have taken here, which we cannot take actually. So there is a mistake in this question. The correct answer will be whatever we are getting, 11.1. Is it clear? You can cross check whatever expression I have given you here. According to this, you are getting option C. But in this, the concentration of H2, equilibrium concentration is not right. It's wrong. Did you understand? Tell me. You can cross check this expression. This expression you will get option C. But in this expression, the concentration of H2 is not right. That is what I am telling you. They have taken 0.54 instead of 0.81. They have taken 0.18 by mistake probably. That's why the answer Kc will be 11.9 according to our expression. Is it clear? Okay, can we move on? Question number 3. Tell me question number 3. The concentration of CO2 which will be in equilibrium with this molar of CO at 100 degrees Celsius for Kc is given. So Kc is equals to concentration of CO2 by concentration of CO. Right, just ratio you have to take. Third one, B is correct. Just you have to write it down. Kc is equals to concentration of CO2 by concentration of CO. Right, CO is given, Kc is given, CO2 we can find it out. Option B is correct. Question number 4. हो गया 2 तारीख. Just a second, I'm coming. Okay, what is the answer? Question number 4. 4, D, and C. You're getting C. NOBr gas, NOBr2 at equilibrium, pressure of Br2 is given, and P is the total pressure, the ratio of Kp by P. It's easy. Ramcharan, what happened? All of other are getting C, you are getting B. Expression for Kp for this reaction will be what? Pressure of NO square, pressure of Br2 divided by NOBr square. Right? So pressure of Br2 is P by 9 at equilibrium. So pressure of NO will be what? Pressure of Br2 is P by 9. So pressure of NO will be 2P by 9. Okay, so we can write pressure of NO is 2P divided by 9 square. Br2 is P by 9 divided by pressure of NOBr. What is the pressure of NOBr? It is okay. So I'll write down the reaction here first. The reaction is NOBr gives NO plus Br2, all our gases, 2 and 2, right? So, okay, total pressure is given P, right? So, for this will be what? Total pressure minus the pressure of NO and Br2, right? Which is nothing but 2P by 9 plus P by 9. We'll get the equilibrium pressure of NO directly. Total pressure minus the pressure of these two. Okay? So, when you solve this, you'll get 3P by 3, so 2P by 3, I guess. So it is 2P by 3. So we'll write here 2P by 3 square. This is equals to Kp. So when you solve this Kp by P, you will get 1 by 81. Option C is correct. Yes? Question number 5. Question number 5. Question number 5. You're getting C 1.6 into 10 to the power minus 23. You're getting 10 to the minus 20. How is possible? Check once. Check your calculation. You must have missed the power. 6 HCHO is there, Purvik. So that will go into the power, right? So HCHO to the power 6 you will get in the expression. You must have missed that. Formaldehyde polymerizes to form glucose according to the reaction. The theoretical computed equilibrium constant for the reaction is this. Okay. So Kc for this reaction will be C6H12O6 H12O6 divided by HCHO to the power 6. Okay. So this Kc value is given, which is 6 10 to the power 22 is equals to 1 divided by HCHO concentration to the power 6. So when you solve this, you'll get the concentration of HCHO will be 6 into 10 to the power 1 by 6 into 10 to the power 22 to the power 1 by 6. This is what you have to solve. So answer you will get here is option B, 1.6 into 10 to the power minus 4 molar. Right? Option B is correct. Glucose will consider as solid. That's why we have taken 1 over there. Okay. Option B is correct. Next one. Tell me this. A gives NB. The reaction is. One more thing I'll tell you here. This is point 2, which is not mentioned here. And this is point 6. This is here. Condinia is getting B. What happened? Tell me the answer. Sixth one. You see, in this question, according to the graph, you see A gives NB. So the change in concentration of A, del A minus of del A will be equals to what? You see here, from this point 0.5, zero point 0.5 to zero point 0.3. This is for A, right? So change in concentration will be what? Minus of 0.3 minus 0.5. So that will be equals to 0.2. Similarly, the change in concentration of B will be what? From 2 to zero point 0.6. So zero point 0.6 minus zero point 0.2, that will be zero point 0.4. So you see A changes by zero point 0.2 and B changes by twice of that. So obviously the reaction will have the ratio of 1 is to 2. So A gives 2B. So N value must be 2 here. So option B is correct. Fine. Now the equilibrium constant of Kc, when you know this reaction, it will be Kc is equals to option concentration of B square divided by A. So that will be zero point 0.4 square divided by zero point 0.2. That will be 0.8. Oh, this is just a second. 0.5, 0.3 is reacting. So concentration of B will be 0.6 here. So 1.6 into 6 divided by concentration of A is 0.3. A gives 2B. It is 0.5 and 0. 5 minus 0.2 gives you 0.3, which is the concentration we have here. And this gives you 2 into 0.2, 0.4. So Kc will be 0.4 square divided by 0.3. 0.4 into 0.4 divided by 0.3. So 16 divided by 30. So approximately zero point 0.5 we are getting. Approximately zero point 0.5, more than 0.5, 0.51 or something we'll get. Finished? Oh, just a second. Initial concentration of A is zero point 0.6, right? So here it should be 0.6. Zero point 0.6, and final concentration of A is zero point 0.3, so this should be 0.3. 0.3 into 2, here we have zero point 0.6. So we have zero point 0.6 square divided by 0.3. 0.3. 0.6 into 0.6, so we are getting 1.2. 1.2, option D is correct. See, actually, this question is based on a graph. See, I didn't see actually where is the point of equilibrium? This is the point of equilibrium, right? Here, the rate is not the concentration of B and A is constant after this point, correct? And that is what the condition of equilibrium. The concentration won't change of A and B. So this is the point of equilibrium where the equilibrium has been established, right? Now here you see these two values are not given. This is zero point 0.2 and this is zero point 0.6 that I have given you. It is not mentioned in the graph, but it is 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5 and 0 0.6. Now from this graph you see the initial concentration of A is zero point 0.6, which I have missed over here. I have corrected now. Initial concentration of A is, if I write down here, A naught, initial concentration of A is zero point 0.6, and when the equilibrium has been established, the concentration of A at that point of time is zero point 0.3. Initial concentration of B is 0, right? And since we have to find out the change in concentration of B, so we require the concentration of B at any 2 point. Okay, so one point is this and another point is this, where the equilibrium has been established. So the change in concentration of B is what? 0 point 0.6 minus 0 point 0.2, that is 0 point 0.4. Change in concentration of A is what? Any at 2 point, right? That will be 0 point 0.5 to 0.3, which is nothing but 0 point 0.2, right? So the difference in the concentration of A and B is in the ratio of 1 is to 2, right? 0 point 0.2 and 0 point 0.4. That's why this mole ratio should be 1 is to 2. That is what the first point, right? Now coming back to this graph again, the second question, the equilibrium constant Kc of the ever graphical study is. Now for this we required the change in the equilibrium concentration of A and equilibrium concentration of B, so that we can find out Kc. Okay, so initial concentration of A is 0 point 0.6, and from 0 point 0.6 the change is 0 point 0.3. So 0 point 0.6 minus 0 point 0.3 gives you final concentration of A is 0 point 0.3, which is easily understood from this graph. Now when 0 point 0.3, to get the final concentration of A as 0 point 0.3, from 0 point 0.6, 0 point 0.3 must react, right? So this is nothing but X we have in this case. And 0.6 minus X gives you 2X here, because the ratio is 1 is to 2. So X is 0 point 0.3, so 2X will be 0 point 0.6. This is the equilibrium concentration of B. So what we can write, Kc, concentration of B square divided by concentration of A at equilibrium. That is what I have done. Understood? Yes, tell me. Can we move on? Okay. Question number 7. 7 we have done. Question number 8. What is this? Question number 8. You're getting A. How it is A? How did you get A, Purvik?